Hello and welcome everyone. I would like to have your attention here. So as our topic suggests, the time machine, today we will give you a brief introduction to it. Once in our life, all of us must have imagined of changing our past or discussed of being interested to go in future. But have we ever thought that our imagination had once been a serious discussion among some of the famous scientists? Some theories, most notably special and general relativity, suggest that suitable geometries of space-time or specific types of motion in space might allow time travel if these geometries were possible. So I now hand over the discussion to my team member for further explanation.
The time machine. What comes to your mind when you hear the word the time machine? Something kind of this, or
probably this.
But the thing is, how did and from where did the concept of time traveling originate? For that, let's travel back in time. 1895. H.G. Wells' novel The Time Machine popularizes the idea of time as the fourth dimension, through which it might be possible to travel by analogy with the three spatial dimensions. The Time Machine is a first hand account of a time traveler's journey into the future. A pull of the lever, and the machine sends him to the year 8,02,701, where the humanity is split into two bizarre races: Eloi the ethereal and Morlocks the subterranean. Credited with inventing the time machine, in this masterpiece, the provocative insight of H.G. Wells continued to enthrall the readers. 1905. Einstein's groundbreaking paper on the theory of relativity introduces the idea of time dilation, the first hint that in real physics as well as scientific fiction, time might be interchangeable with space. 1927. The physicist Arthur Eddington first introduces the concept of the arrow of time and its relation to entropy in his book entitled The Nature of the Physical World. The arrow of time, also called time arrow, is the concept positioning the one-way direction or asymmetry of time. It is an unsolved general physics question. 1935. Together with Nathan Rosen, Einstein shows that under certain circumstances, it's possible to have a shortcut between two different points in space-time, a wormhole even past and future. 1974. Physicist Frank Tipler designed the first real-time machine. According to the design, a Tipler cylinder would use a string of rotating neutron stars to produce a closed, time-like curve. Tipler cylinder, also called a Tipler time machine, is a hypothetical object theorized to be a potential mode of time travel. 1992. Stephen Hawking suggests that there might be an undiscovered law of nature that prevents closed time-like curves, therefore preventing time travel into the past from occurring. 2009. Stephen Hawking holds a party for all the time travelers, which was widely published, but unfortunately, no time traveler turned up to the party.
Coming forward, now let's talk something that is both science, and sense in it.
Let's begin it with a question. Can you answer the simple question, what is time? This question, that seems to be easy, can probably trigger the world's greatest mind. So, is time traveling possible? Yeah, it's scientifically possible. Time traveling is not only possible, but we have already done it, and you have done it too. Every time that you have been in a plane, train, or a car, you have done time traveling. That is because time is not absolute, it is wrapped by velocity and gravity. Peggy Whiston, the first female commander of the International Space Station, she spent a lot of time in the space. 665 days to be precise. And here's the thing, because of all time she spent up there, she's younger than she had been on Earth. This is something called time dilation. It basically says that time is different for different observers, and that it can be wrapped under velocity and gravitational potential. It's these properties of time that has excited the imagination of the then would-be time travelers ever since Einstein announced his theory of special relativity. So, how do we build a time machine? Ron Mallett uses the general theory of general relativity to twist the very fabric of space-time using light or laser to be precise. But still, why do we don't have a time machine yet? For that, there comes the following reasons. We need vast amount of energy to go with it, and we require vast amount of money, which so far no one has yet been willingly to foot the bill. And the experiment might need to be the size of the universe for it to actually work, or you need as much energy as would be required to form a black hole, or that the equation don't even work with our particular universe. So, we conclude that time machine, though scientifically possible, is an hypothetical concept, and it is not as easy to handle as we have seen